Okay, this is the next video for Module 5, and we're going to look at hypothesis testing again. And this time we're going to talk about the hypothesis test of Chapter 11, which includes the goodness of fit test. And then the last video we'll talk about the test for independence. So I'm going to show you basically the steps that you're going to use for goodness of fit, and then we're going to go from there. Okay, first of all, it's very similar to how we did a hypothesis test for Chapter 8. You state your null and your alternate hypothesis. You find the test statistic. Now this is done a little different. It's done in the calculator. So I'll have to show you how to do that. And you can see the calculator steps on this. Step 3, get the critical value from your chi-squared table. Okay, this time you have to use a table. Step 4, you're going to compare your test statistic with the critical value. And step 5, you're going to state your conclusion. The good news about goodness of fit is that your hypotheses are pretty much the same every time. Unlike Chapter 8, where you could have a left-tailed, a right-tailed, or a two-tailed, goodness of fit, HO is always your given values, and I'll show you how to word that in the problems. And H1 is, all you have to say is at least one is different. You can say the same wording every single time. Alright, so let's look at an example. It's kind of lengthy, so bear with me. Okay, this problem reads, we're talking about flat tire and missed class. Alright, this is a classic tale, involves 4 carpooling students who missed a test and gave, as an excuse, a flat tire. On the makeup test, the instructor asked the students to identify the particular tire that went flat. If they really didn't have a flat tire, would they be able to identify the same tire? The author asked 41 other students to identify the tire they would select. Use a 0.05 significance level to test the author's claim. Alright, so let's underline some things here. Okay, and this should be 40. This is a typo here. Alright, so my sample size is 40 students. Okay, my significance level is 0.05. And we're going to test the author's claim that the results fit a uniform distribution. Okay, what does the results suggest? Okay, uniform distribution means that every possibility, in this case selecting each of the 4 tires, are all equally likely. That's a really important phrasing when you're talking about how to set up a goodness of fit test. That's going to help you in setting up your H1. Alright, here we go. First thing we want to do is state our hypothesis. Alright, we're going to say that in this case, since we're talking about all the tires, that the probability of guessing the left front tire is the same as probability of the right front tire, which is the same as the probability of the back, let's see, left front, right front. I should do it like this. Left back and right back. Okay, all of these are equally likely. Okay, and you can word it any way you want, but you want to make sure you somehow say, and you can even write out in words, that each of the 4 tires all have equally likely chances of being selected. Our H1, at least one is different. Alright, step number 2, we're going to calculate our test statistic. And like I said, you really need to see the calculator for doing this. So pull out your calculator steps to figure out how to do this. But basically, you're going to enter information into list 1 through list 6. And it's very detailed in the calculator steps. So I'm going to go see that. I'm just going to tell you what the answer is right now. Okay, my test statistic. It's symbolized by the chi-squared, is going to be equivalent to 4.6. Okay, and like I said, just see the calculator steps on how to do this in the calculator. Okay, step 3 is I'm going to get my critical value from my chi-squared table. So chi-squared critical value, okay, chi-squared CV. I'm going to go to my table. Now again, see your table for how to do this, and if you're not sure how to read the table, then please make sure you ask questions or get some help. But because we have a significance level of 0.05, I'm going to look for my chi-squared of 0.05, my degrees of freedom. This is very important when you're looking for what you need. You need degrees of freedom. Okay, the way you find degrees of freedom is by taking k minus 1. K is the number of categories. okay? Number of categories. Okay, in our case, we have 4 categories. Front tire, left and right, and back tire, left and right. So our degrees of freedom is 4 minus 1, which is 3. Because you need to know degrees of freedom and you need alpha, which in our case is 0.05. That was given in the problem. Those are going to be the 2 things you're going to look for in your table. And once you do that, you're going to find that your critical value is 7.8147. All right, step 4, we're going to look at comparing. And again, you compare your test statistic to your critical value. Okay, test statistic to critical value. And you can see the notes for how to determine what your relationship is, but if your test statistic is smaller than your critical value, okay, then you're going to fail to reject. All right, if that had been greater, the other way around, test statistic bigger than that, then you would reject. So those are your 2 options. If it's less than your critical value, you fail to reject. If it's more than your critical value, then you reject. And then step number 5, you're going to write your conclusion. Since we're failing to reject HO, we're saying this could be true, but we know this is not. So H1 is definitely not true. So basically we can say there's not sufficient evidence to warrant the rejection of the claim that the results fit a uniform distribution. Okay, I'm going to write that out. There is not sufficient evidence to warrant the rejection of the claim that the results fit a uniform distribution. All right, what is that telling us? Basically what we are saying, let me put this up a little bit more. Okay, basically what we're saying is that we can't reject this, so this could possibly be true. Again, we never say accept the null, but we're saying that there's a possibility this is true. But basically what we showed is that our evidence does not support that one of these is different. So what does this tell us about these students? Well, since we're saying that the claim that they're all equally likely is possibly true, then each of the tires have the same probability of being selected. So if these students are lying, the teacher's going to know, because there's not one greater chance of them picking a certain tire. So all 4 of them could pick a different tire. So if they are lying, the teacher's going to know. Okay, so this is one for equally likely. Okay, the other type is when they're not equally likely. Basically, you work through this data set, everything the same, but how you set up your null is a little bit different. All right, so here's problem number 2. Workplace accidents. In a study of 100 workplace accidents, 22 occurred on a Monday, 16 occurred on a Tuesday, 15 occurred on Wednesday, 16 occurred on Thursday, and 31 occurred on Friday. Use a significance level of 0.01, here's my alpha, to test the claim that workplace accidents are distributed as follows. So this is my claim. All of this. This is going to be my H sub 0 because all of them are different percentages. So we're going to set up H sub 0 a little bit different. Okay, so the first thing I'm going to do is set up my H sub 0. Alright, H sub 0, the proportion of Monday is 0.25, proportion on Tuesday, 0.15, proportion on Wednesday, 0.15, proportion on Thursday, 0.15, and proportion on Friday is 0.30. Again, H1, at least one is different. Okay. Number 2, we're going to set up, again, we're going to go in the calculator, do all those steps to calculate our test statistic. Okay, this time, Okay, this time our test statistic is going to be 0.5267. Okay. Step 3, we're going to read our table. This time, degrees of freedom. I have 5 categories. So it's 5 minus 1, which is 4. Alpha is 0.01. So my chi-squared critical value from my table is going to be 13.2767. All right, step 4, I'm going to compare my test statistic to my critical value. It's less than again, so this is going to give me the same results. I'm going to fail to reject the null, which again means that my claim could possibly be true. So I can say the same wording I can use in my last one, there's not sufficient evidence to warrant the rejection. Or I can say, this is another way you can word it, there is not sufficient evidence to support that at least one given proportion is different from the claim. Okay, that's another way I can word it if I'm not going to use the claim in my support or the claim in my wording of my conclusion. So there's not sufficient evidence to support that at least one proportion is different from the claim. So you're saying there's not sufficient evidence to support H1. Okay? Because we're saying that H sub 0 could possibly be true. So we could say it like that, or you can use the same wording that I used in the last example, and I could say that there is not sufficient evidence to warrant the rejection of the claim that the proportions are as given. Okay, so that's your goodness of fit.